Welcome back. I'm John Ferguson Smart, and today in the Professional Java Development and Test Automation Skills program, we're going to be looking at a very useful design principle called the signal level of abstraction. I find it's one of the most important aspects of keeping your code easy to maintain and easy to read. So in this tutorial, we'll look at what the signal level of abstraction principle is, and we'll see how it gives you quite a few ways of making your code simpler, more readable, more reusable, and easier to maintain. In this tutorial, we'll be looking at three main ways that you can use the signal level of abstraction principle to simplify your code and extract unwanted complexity. First of all, we'll look at how to separate your business logic into methods in order to make the flow of your code more readable. Secondly, we'll be looking at how to extract entire pieces of logic that you think maybe shouldn't really be in a particular class and place them in a separate class entirely. And this opens the door to reusing the business logic that you've placed in those classes in other places. Finally, we'll be taking this idea a step further and using the builder pattern to make readable, fluent, domain-specific languages to express your business logic in a much more declarative way, which again makes it much easier to maintain and to reuse. Now, the signal level of abstraction principle is a design principle that Robert Martin, or Uncle Bob, described in his clean coding book some time ago, and it's probably one of the most important principles when it comes to making your code more readable and more maintainable. The principle essentially states that all elements, all statements in a method should be at the same level of abstraction. So all the statements in a method should have the same level of detail, would be another way of saying it. The reason for this is our mind has trouble focusing on several levels of abstraction at the same time. For example, if you want to focus on the control flow in a for loop, it's hard to focus on the data processing aspects at the same time that we're doing inside that loop. This principle is actually also closely related to the idea of separation of concerns, which is a principle that dates back to the 70s, was first expressed by Dijkstra in the 70s, and which describes how when you look at a complicated problem, you can only really effectively look at one aspect of that problem at a time. If you try and think of several things at the same time, it might start to get confusing. The easiest way to demonstrate all of this is not to look at slides, but to look at some code. The first method we'll look at is extracting methods from a complex block of code. Let's go to our sample project, the Vet Clinic project, and we're going to check out the Kata SLA for signal level of abstraction start branch. And this is where we're going to start our exercise. Inside this project, we have a package sla.kata and a class called whenFeedThePets. Now this class is a relatively simple one, and we can understand the principle of what we're trying to do from the test, which is what we are trying to get at, obviously, with our acceptance test and our unit test. This test says that we should feed each pet in the hotel. Sounds reasonable. So we've got a pet hotel with 10 pet checked in, and when we say feed the guests, we want that each of the hotel pets is well fed. Let's run this and see if it works. And we have a passing test. Now it's time to look at the code that implements this feature and see if we can improve it in any way. Let's discover how a hotel actually goes about feeding the guests. We step into this method, we get quite a complex bit of logic really. We have basically a loop over all of the pets, a for loop. So we're going to doing something with each pet, and then for each pet we're going to check the breed. If it's a cat, we're going to feed it 10 times the weight in kilos, so we're feeding it with an amount in grams and a pet food, and we're giving the cat kitty cat. On the other hand, if it's a dog, we feed 20 grams for every kilo the dog weighs, and we give it Fido's food. Now, you'll remember what we were saying about levels of abstraction. Here we have a for loop. And inside the for loop, we have an if which checks the breed of the cat and then makes a calculation, a fairly obscure calculation, you must say, based on the number of grams per kilogram and an appropriate breed. We're thinking about at least three things here. We're thinking about the collection, working through the collection of pets. We're working out a different process for each breed. And then for each breed, we're making a calculation based on a different brand and a different weight calculation. The first thing we could do to simplify this is simply get this out of the for loop. A for loop should contain a loop and then another method at the same level as the loop, which is pretty much one or two methods, nothing more, and delegate the rest of the work to someone else. We can do this in IntelliJ by doing an extract method. Now I did a option command on Mac, it would be an Alt Control M on PC, and let's make a method. So we are really, if we look at this logic, what are we actually trying to do? We're trying to feed a given pet. So we can just say, call this method feed pet. Let's see what the code looks like now. So we have for pets, each pet, feed the pet. We can see this reads a lot more logically. We don't have to worry about how we feed the pet. We just delegate it to this method underneath. And this is the first and most simple way of simplifying for loops or simplifying conditions. We can do this with for loops or if statements. Here's another example. In this feed method, now we don't have a for loop, but we still have an if and then a calculation, else if, and then another calculation. In this method, we're doing two things again with two levels of abstraction. The first level is reasoning about the breed of the pet. The second level is reasoning about how much the pet should be fed. So, how could we refactor this? One thing I could do here is extract this code into an external method. Now, once again, I can do an extract method. Now, I can do it with the shortcut, or I can also do it with the menu, refactor, extract method. And we might say something like feed cat. And IntelliJ is clever enough to propose some slight modifications where we pass in the amount and the brand, and we would be able to adapt use this logic in both cases, but we don't want to do that for now. We'll just leave it as is, and we'll have feed the cat. And we'll do something similar here. So I'm just going to say feed the dog. Once again, I keep the original, and now we have, if the pet get breed is a cat, then feed cat. Otherwise, feed, let's change that so it reads consistently. Otherwise, feed dog. And we've encapsulated the logic about how you feed a cat or how you feed a dog in a separate method. So effectively, what we've done here is simplified the code to some extent. Now we have a loop over the pets where we call one method, feed the pet, and within feed the pet we make a decision and then call another method under the hood, and then each of the separate feed dog and feed cat methods contains a logic that that decides how a particular pet should be fed. That's a good start. In the next section though, we'll see how we can do better. This code is certainly an improvement on what we had previously, but is it really the job of the pet hotel to know exactly how much a cat and what brand a cat and a dog should be fed? If we apply what we call a single responsibility principle, the hotel should be responsible for taking care of booking pets in, checking pets in, keeping the pets list of pets in the waiting list and so forth. The feeding business should be someone else. It's a specialist job after all. So wouldn't it be nice if we could say something like, rather than having this conditional logic here, where basically we're checking for a cat, then doing something, if we're checking for a dog and doing something and so forth. If we had hamstered, we'd have to change this code. And it becomes very tricky to modify. The code becomes complicated quite quickly this way. If we use what we call the signal responsibility principle, as we said, we can decide that this should not be delegated to other methods like we've done here within the same class, but it should be delegated to an entirely different object whose job is to feed the animals. Wouldn't it be nice if we could use a special object, say a food dispenser, whose job it is to dispense food to the animals? So I've created this food dispenser. I need to create the class. I'm going to put it in the models class, source main Java, and now instead of all of this, I can refactor this into an external method. So I'm going to write the code I would like to have. Food dispenser, feed the pet. Now that doesn't exist, but it's going to be a copy of what we already had. We're not going to change the logic at all because we're refactoring. So I'm going to create the method feed, and I'm going to import my logic. Now obviously feed cat and feed dog don't exist. So we can go and copy them again directly from here. Once again, we're not changing the logic, we're merely shifting it into another place. So now let's look at what we have. We have a food dispenser, feed the pet. All of the pet logic has been delegated to the food dispenser, and now we can refactor at our leisure to make this cleaner or more extensible. But the logic about how to feed a cat and how to feed a dog now lives in the food dispenser and not in the hotel, which is arguably a better place for it. But if we look at this code, we can actually do better than this. If we go back to our hotel, we have our feed the guests and we have our food dispenser doing the feeding. In fact, a food dispenser is really responsible for preparing the meal and the pet is responsible for eating. So wouldn't it be nice if we could just say something like this? Pet, eat something that the food dispenser prepares. And now our food dispenser, we can make the food dispenser belong to the hotel. We no longer need this method. All we need to do is refactor our pet so that it accepts a meal directly. So if we have a look at our pet class, at the moment we have the pet being fed, and the pet feed will basically add the meals given is a list of meal objects. A meal object is an object with an amount in grams and a brand. Now, arguably now in this class we have the pet who is creating its own meal. We don't really want that. What we really want is the pet to eat a meal. That's all pets will do. They don't create their own meals, they eat them. And someone else creates them. So we say eat meal. The pet is now eating the meal that's given to it. So we've simplified this code quite significantly. And if we go back to our hotel, we now just need the food dispenser to prepare a meal for a given pet. So let's create the method, prepare a meal for a pet, and we can see how we can refactor our existing code to make that work. Now that our food dispenser is focused on creating a meal, things become a bit simpler because we can just say create a new meal, and a meal will take a couple of parameters. Now that our food dispenser is simply responsible for creating a meal for a pet, it makes things simpler. We can just say return new meal, and a meal, if we remember correctly, takes an amount in grams and a brand. So we could write something like write amount of food for the pet that we have and write food for the pet that we have. And with those two methods, we should be able to figure out the right meal for our pet. So let's just get rid of these other methods that we no longer need to make things a little bit cleaner. Actually, let's leave them there so we can remember them, but we'll comment them out and remove them shortly. We do want to remember what the algorithm is because we're refactoring and we don't want to break anything. So, right amount of food for pet. Now, the right amount of food is the weight in kilograms multiplied by a number. The number varies in function depending on the pet. So the first thing we might do is say, well, let's see, weight in kilos times grams per kilo by pet. Now what I'm doing here is creating a map. I want this to be a map of going from pet breed to the number of kilograms I want. So this could be something like a hash map. A map going from breed to integer. I'm going to instantiate these values with the right values for each type of pet. I'm going to remember to make this static so that I can access it. Now we can see that dogs get to have 20 grams per kilo, whereas a cat will only get 10. And there we have our right amount of food. Let's check out how we do the right food. We can do something very similar. Brand for breed, and we'll create like our So what we're doing here is we're simply returning the brand for a particular breed and we're asking the breed of this pet. Let's refactor this a little bit and put the constants up the top in a more conventional place. We can remove our commented code and now we have some code that's a lot more neat and tidy. Let's refactor, put those statics together. You'll notice this is a very declarative style. We're saying the brand for breed for each brand, and we're saying the grams per kilo by pet for each breed. And then we're simply using our knowledge about the pet that we're preparing the meal for to get that information. Doing this means that we've got a much more clearer expression of the algorithm that we're using, which makes it simpler, it avoids conditions, and makes the code more bug-free and easier to maintain. Let's run this and see if it works. And so running the test has demonstrated that with all the refactoring that we've done, we haven't broken anything. It's very important to make sure that every time you do refactoring that all of the tests still work. Let's summarize our newest strategy. Our feed the guest is now going through the list of pets and doing a pet.eat, so feeding the pet a meal created by the food dispenser. The food dispenser is a new object who's responsible for creating meals for the pets. When the food dispenser creates a meal, he needs to know the right amount of pet for the food and the right food for the pet. And we store these declaratively in a set of maps by breed, both of them by breed. One will give a pet food by breed, the other will give a quantity by breed. And that's pretty much it. What we've done here is effectively applied the single layer of abstraction and the single responsibility principles to make the code a lot more focused and a lot easier to maintain. So we've got an exercise in another part of this code base which will let you play around with these methods quite a bit. Until then, it's John Smart signing off. Until next time.